Hey, I am Brian Costanza, and today we are going to do a tutorial on using Bezier curves to make generative art. Now, going back to what originally inspired this was I saw a post by Anders Hoff on his website inconvergent.net, and about a year ago for a class project I kind of mimicked what he had done because I was really inspired by what I saw just using these spline curves, and I went about trying to recreate that as best as I could. And what I did is not an exact recreation, but it looked pretty cool, looked similar. It was inspired by what I saw there, and this tutorial is going to be based more on my work. I've never actually looked at the code that was used on Inconvergent. I just looked at the outputs and thought about a way that I could do something similar. So this tutorial will be working through the steps to do something like that, and then you can take it to wherever you want to go after that. The main ingredient will be Bezier curves, so we will kind of tackle those first, and then we will move on to animating them. Then we will turn them into classes, well, into objects using classes to give us a little bit more control about how they are displayed and how things change, and then we'll go from there. All right, let's jump in and we'll start by setting up our file structure, and then we'll get the processing template put into Sublime Text, and then we'll rock. So I'm already in my Sandlines project here. Then I'm going to create a new folder and I'm going to call it YouTube tutorial. And in the YouTube tutorial folder, I'm going to have a build folder. And this is really where I'm going to do most of my work. And then in Sublime Text, I'm going to use my text expander shortcut. I'm going to take out a little bit of this because I'm not going to use it today. And we'll get going. So, almost get going. I'm going to save this in the right place. Let's see, Dropbox, Sandlines, YouTube build. And I'm going to save it as build.pde. Okay, that's looking good. Now my syntax highlighting is there. And the first part, which is very important, maybe less exciting, but very important, is to set up the screenshot saving functionality that we want. This will be a little bit different than what we've done before because we are going to be saving screenshots like for every draw loop this time instead of just one time every time we run the code or every time we click the screen. So I'm actually going to set it up so there's a new folder created every time that I run the sketch, and then inside of that each screenshot will just have like a counter on it basically. And just go ahead and make a couple of functions here. So I'll do save screenshot as one function, and it will not take any parameters. And the way I want to organize this, I think I'll even do another function here that will be like create screenshot string. What would be a better create date time string? I like that. Or yeah, we could probably do something better, but see, create date time string. We'll do create save string. I think that's a little bit better. All right, looks good. Now in the create save string, we're going to, I'm going to change the indentation real quick. All right, in the create save string, so I'm thinking we'll have a folder that's going to be something like screenshots, and then I'll have the code added to the end of that, the date time code. So let's see, date time code equals, and we'll do years, add that to months. And months is not going to be 2 digits all the time, but I really want all of these to be fixed width, so I'm going to use the nf function, and I'll pass it the month. Ooh, and it's not years, it's year. And then nf month, I want it to be 2 characters, and I'm going to repeat this for each. So month, day, hour, minute, second, nf month, day, hour, minute, second. Okay, That's going to be that whole string. So date time code. That looks good. And I'm not going to leave that right there. Okay, so then the folder name will be equal to screenshots plus date time code. And I'm even going to add the slash at the end of that, so we were already ready for the next spot. Will folder name? No, it'll be, I think, more descriptive to do this. Okay, so that looks good. And I'll do something a little bit different. I'm going to define some of these variables just right above the create save string because they really don't need to be, although they are global variables, we don't need to kind of clutter up the top of our file with that stuff, so we will do it here. So we have a string called date time code, and then we have a string called folder name, and as we're working on this, we don't need to declare date time code up here because it gets put into the folder name. So let's just define it right there. So folder name is declared up here to be global, and then we define folder name there. Date time code we're just going to use here. So I'm just going to define it within this function to try to keep things a little bit less cluttered. And then the rest will be done in screenshot, I believe. So let's do save, and then we just put in the string of the file that we want to save, and it's going to be folder name plus, we'll put the slash in there, and then I'm going to do capture, and then going to add to that, we'll use the variable called frame count that is available within processing, and we can just type it like that. You can see it changed syntax color there, so it is being recognized as the variable. This is really similar to like height and width that you can use. Once the canvas size is set, you can use height and width, and that's available everywhere, and processing kind of just has that going on in the background the whole time. And then we need to give it a file extension. So we'll just add a PNG there at the end. That's pretty good. We could probably have cleaned this up a little bit better or done different things. Or actually, we could combine that part right there. So the folder name would be screenshots, then the date time code, and then within that folder, it's going to have screenshots that are called capture, and then it's going to have the frame count. Oh, but I do want to format the frame count. So I'll use NF once again, and I want it to count up to, this could actually run a pretty long time. So I think having four characters, 4 digits, a width of 4 would be a good choice. So we can go up to 10,000 screenshots. That seems good to me. Okay. Anything else we need to do here? No, I'd say let's go ahead and move on to making our graphics. So one thing to keep in mind is that, well, how to say this? This can get pretty complex at this point. We're going to do a fair amount of math. We are going to have a lot of variables running around. We are going to use some arrays, which, once you get used to them, are great and super useful. But if you're new to them, they can be a little bit daunting. But in any case, we pretty much are not going to be able to do this without using some arrays, and it's a really important thing to learn, so we're going to be doing that today. So let's just go ahead and start building this up. Where to begin? So we have in setup, we have draw. Oh, one thing we did leave out though is now in draw, we do want to do save screenshot. There we go. Okay, looks good. So let's just get started by putting a circle where we will, well, not where we'll need it, but just in a place that makes sense to start, and then we will start expanding from there. So let's go in here and thinking a little bit ahead to what we'll program later is we know we're going to have Bezier curves to make these really nice lines, these kind of fluid looking lines, and those are going to use 2 anchor points and 2 control points for each one. And so what we're going to do is we're going to put down an anchor point first, and that's kind of like the terminology, or we're going to use that kind of naming when we are making these variables, so that it makes sense when we convert it over later to be this array based, like multi-piece code that will show everything that we want to do. So why don't we just go ahead and call this an anchor, like the anchor, and then we're going to have the coordinates in 2 different arrays. So the x value, or the x coordinate for this anchor, will be anchor x, and right now we're just going to say that it is at width over 2, and I'm going to declare it as a float right now. A lot of times these coordinates I will use the integer type, because really it makes sense to graph it in that way, but we're going to be doing so much math in this case that if we keep it as an integer, we're going to end up with some data issues down the road, and there's really no harm in just using floats at this point. We don't have any major memory concerns or anything like that, so we're just going to use floats. And now we have anchor y, and we'll set that at height over 2. Wow, I did height over w. It's width over 2, height over 2. Those are going to be our coordinates for the first anchor that we put down. And I know that we will want to plot that and see where it is, so I'm going to put background up here, background gray 255 to make it white, and then below here we will do circle, anchor x, anchor y. All right, and for this circle, I think we do not need to have an outline, so we'll do no stroke, but we will fill it with black so we can see where it's at. All right, let's just run that real quick and make sure we're on track so far. Nope, expecting semicolon found, right angle bracket at line 32. Oh, yep, right here. Forgot my semicolon. All right. Oh, now 33. String for name. Oop, forgot a semicolon there too. Wow, all kinds of mistakes. Oh, right, I didn't set a diameter for the circle. I would say, I don't know, 8 pixels for now. There we go. All right, we got a dot right in the center. Looks good. So now what would make sense is to do the x and y coordinates for the control points. And what we want to do is we want to think about there being a control point on the left side and on the right side of each of these anchor points, and that's what we're going to show in our code as well. So let's go ahead and do float, and then control, we'll do control left x equals, and I don't know, it's going to be offset from anchor x actually, so we'll use that as a reference point, and we'll do anchor x minus 50 pixels. Why not? We're going to do something similar on the next line. So control left y is going to have the same reference to the anchor point, and actually it's just going to be at this point completely horizontal, directly horizontal, or from it, so we'll use the same y. And we're going to use the same kind of language for the right control point. So control right x, control right y. So this is going to be anchor x plus 50, and anchor y we will leave the same. Now I'll go ahead and make some new code to show us that. I'm going to make that a little bit smaller. Let's see. Circle, control, Control left X, Control left Y, 5, circle, Control right X, Control right Y, 5. Okay, now we have 3. That looks good. So anchor in the middle, control points on the left and right, and we're ready to expand. Oh, let's add one little indicator here. Let's go ahead and draw lines between them. So line, and then we're going to use the anchor X, anchor Y, oops, and then we're going to draw from there to the anchor left, control left, X, to control left, Y. We're going to do the same thing to the right control point. Did we get it? We may have gotten it, but we don't have any stroke. So let's go ahead and do a gray stroke. I'm actually thinking about changing this to a brighter color, like a gray, like a light gray. And that should do it. Okay, that does look good, but we've lost our circles. Oh, we didn't lose our circles. I put in white instead of gray. I did 255 instead of 225. Okay, that looks good. So now what I'd like to do is I want to start moving these control points a little bit to give them some motion, and I want to do that using some Perlin noise. So where should we put our Perlin noise in? We have anchors, we have control left X, control left Y, right X, right Y. Okay, what I'm thinking is that we should kind of think about this as control points on the end of like a lever that's going to move like that. And so I'll move that lever like angle with the Perlin noise. So I will go ahead and define something up here, and we'll do float. Let's see, control angle, and we're gonna do degrees. And since all these conversions between units can get a little bit dense, I'm gonna actually even add this to the variable name just to make sure I'm really clear on keeping track of what is going on. And this float of control, angle, and degrees, what I want to do, so I want to take it from Perlin noise, and then I want to map it to an angle. And through some other playing around I've done, I think that a good range is between positive 60 degrees and negative 60 degrees. And then we also know that our Perlin noise function, it returns values between 0 and 1. So what I'm going to do is I'm actually going to use the map function. And what map does is that you have an input value, which is right here, highlighted value, and then you tell it what the range is for that input value. In this case, it would be 0 to 1. And we'll put that in the 1 range there. And then you tell it what output range you want. So I can say, hey, I'm going to give you a number. It would be between 0 and 1, and I want that to be mapped to the range of negative 60 to 60, for example. So I'm going to leave value there right now because we'll put in another value up ahead, up above, to make sure our code doesn't get too complex. So the low is going to be 0 with the input. The high will be 1. And we want it to run from negative 60 degrees to positive negative 60 degrees to positive 60 degrees. And we'll do that with the noise function. So we'll go ahead and say we have a float here that is, I don't know, control or I don't know, angle noise value. Sure. And we'll use the noise function. And let's see, do we need to... Yeah, we probably do need to be careful with this, but we can actually save that for later. We'll change that noise function later to make sure we're not pulling the same noise for each part. So we will go ahead and let's use, for now, we can actually just use the frame count as sort of our base. So we could put in frame count and then our noise scale like before. So let's do, we don't have this variable yet, but we'll write it there. So float noise scale, that's going to be equal to, for now, we'll try 0.1. I think we'll probably reduce that later to make things smoother, but I want to see things bouncing around now. So we're not gonna. Okay, frame count times noise scale. So that would take some small steps through the Perlin noise. That will give us our control angle. Okay, and we should put this in for the value there. Okay, that looks good. Now, though, we want to change these numbers to have some trigonometry that reflects the trigonometry, yeah, the trigonometry to reflect the geometry that we've just sort of developed. So the left x, that will be anchor x minus 50, and let's go ahead and do another float, which would be, see the control, we'll call it control radius. So that'll be the radius of the circle that those control points are kind of like floating on. And we'll set that equal to 50, which is what we had going on here. Replace those. Okay. But then this control radius will be multiplied by this trig function to give us the right position. So for the x, it will be cosine, and cosine in processing takes radians as the input, but we've been doing things with degrees, so we'll convert it with the radians function, and then we put in degrees, so control angle degrees. Okay, looks good. Well, there's an extra semicolon that popped in there. And we will do the same thing for control right x. Okay, then for the y, we will go ahead and do plus in both cases, and then control radius times the sine of radians of control angle degrees. Take out that extra semicolon from the autocomplete. That looks good. But no, we do want, so anchor y, a minus. Well, to keep it consistent, we'll do a minus there, and then we will do plus on the other. It's possible that that is reversed, but it's probably easier just to run it and then debug it later. Let's see this run. Oh, okay, yeah. It seems to be moving around as we wanted, so we are good to go on that. This feels like it's going fast. All right, so now that we have that being drawn, I think that it probably makes sense to go ahead and convert a lot of these over to being arrays of points or arrays of values, arrays of floating point values that we can then just specify how many anchor points we want, and then it will automatically create all of those. So let's do that. Anchor x, that will definitely, oh, I know. So we're going to do this within a for loop too. We're going to define all these values in a for loop, so we might as well just make the for loop now, and then we'll move things into the for loop when we've fixed them. Now, the number of times we'll need to do this is how many anchors we have. So right up here, I will make a global variable, and I'm going to make it an integer this time for sure. And what this will be, we'll call it anchor count. And we'll just say it's equal to 5 right now. That's good for me. Or, no, let's move this up to setup. So this is a very important value because our whole program is basically going to look totally different based on what we set for anchor count. So I'm just going to declare it up at the very top because it is an important global variable. And for the anchor count, I'll set it to 5 here in setup. Okay. And then I know that we're going to want to run through this for loop for each anchor. So I int I equals 0, I is less than anchor count. That seems good. Okay, so let's start with this anchor x. Right now, anchor x is a floating point value, but we do want it to be a range, or not a range, an array of floats. So we'll do float anchor x equal, and then we're still going to run into an issue because we are declaring it in the for loop. Okay, we need to move this out of the for loop. We'll do it right here. Float anchor x equals new float, and then the number of points will be equal to the anchor count. That looks good to me. We'll debug that in just a moment. Okay, so now we take out this declaration, anchor x equals, and this is probably another good place for our map function. So we know that the very first anchor will be some distance from the left side of the screen, and the other one we want the same side from the right side of the screen. And I often just have that as like width over 10 as kind of a good margin. And yeah, that's totally fine. But now what I'm thinking is we could do map again, because we're just going to take these steps across, and it's really easy for us to know what the range of the inputs and the outputs should be. The input range would be 0, 1, 2, 3, 4. Well, that's it. Yeah, 0, 1, 2, 3, 4 for the indices for 5 anchor points, and we'll just use that in map. So the input will be I, and we know that that's going to run from 0 to 4. And we know we want that on the screen to run from width over 10, so a little bit from the left side, to width times 9 over 10. And that would be good. Now, we're not setting all of the values of anchor x equal to that. We're only setting the ith value equal to that. Yeah, that looks good. Now, I think we should be able to run this, and nope, we won't. We will have some issues down there. So let's just keep going and convert all of this over now. So now we have anchor y, and we also need to declare that up above, but anchor y of I, for now we will leave it at height over 2. We need to use the same kind of syntax for anchor y. That seems good. And then noise scale, that's going to be the same for all of them. And then angle noise value, that will need to change. So let's see, so it will need to change in the for loop because the noise value will be different for every point. So that's an array equals, same as that. that seems good. Angle noise value of I. And then we said earlier we would need to modify this to make sure they don't pull from the same noise scale. And you know what I think may be easy? I know that if we take jumps of about 1 in the Perlin noise space, they end up either totally or very nearly uncorrelated. So I'm just going to go ahead and add I to just get these spaced out across the Perlin noise space by a fair amount. And that's good there. And then the control angle degrees. Oops, I did copy. We should cut that though. Make that the ith control angle. And we want to define it up here too. So we'll just copy that, paste it here. Okay, that looks good. And then looking in here, noise scale, yeah, that's still a scalar, that's fine. Control angle degrees, and we have angle noise value. So we want to make sure that we are only pulling in the ith angle noise value there. Okay, looks good. Control radius, that is going to stay unchanged. I'm going to put that next to the noise scale. I'll clean this up a little bit. Okay, so these are all going to take pretty similar operations, so let's manage them all at once. And then I'm going to also paste them up here, but we need to replace all of this with what we have done up above as well. Okay, and then we remove the declarations here. And now we need to add a lot of these indices. So here and here, that's a scalar. And control angle degrees is also of I. And then to draw these, we would want to do that in the for loop too. That didn't paste very well. Here we go. Oops. A little mistake here. Clean it up. Oop, oop. Okay, I'm ready to try this. Let's see if it stays together. Cannot convert from float to int, line 31. Who said they need? Cannot convert from float array to float. All right, let's check our processing, documentation. So array, new, and then it is in brackets. Nope. Here we go. Oh no. Yeah, basically it said create a new array of floats and then set it equal to this single scalar float, and said no. All right, we're almost in action. So those are moving independently really nicely. And now all we have to do is draw some Bezier curves between each of these. How great is that? So the way we're going to do that is we're going to do a new for loop. So this for loop goes through every single anchor point and its associated control points. And that's great, but what happens is we end up with one less section than control points. So if there's five anchor points, we'll have four Bezier sections, and we could run some magical code to make it work up there, but to keep this kind of different code in different sections that's also using different indices, we're going to just separate it out over here. And so you said it's one less than the number of anchor points, so we'll do anchor count minus one as the limit here. And then for each one of these, we do want to draw a Bezier curve. So we can see there's the x1, y1, cx1, cy1. That's the anchor point 1x, anchor point 1y, control, control, and then the other control point for the second one. And this is all good. I'm going to put these extra tabs in to just kind of help keep things lined up. And so what I'm thinking we need to do is we need to draw, so the first anchor point will be J. So it's anchor X, J, anchor Y, J. That sets the first anchor point of this Bezier curve to the first anchor point in the list. That sounds good. And then it's going to be control right X of J, and then control right Y, J. And then it's going to be the control left X, and this is going to be of J plus 1 because the very first left control point is on the left side of the very first anchor point, and we're not drawing a Bezier curve over there. We are 1 over, so we do this kind of stepping method through. And then it's going to look similar for the anchor X of J plus 1, and then anchor Y, J plus 1. And I don't know what draw settings will come down, but let's just define them here. We'll say no fill, and then we want stroke, weight. We'll do to 3 for now, I suppose. And then we want the stroke color. Let's go pick something here. Oh. Let's try this one. And I'll run it. Stroke weight. Oh, stoke weight. It's not stoke weight. We need an R there. Okay. Something's wrong, but it doesn't look too bad. Right X, right Y, left X. Oh, left Y. And I never did check that. Yep, so that looks good. I didn't check that. Uh-oh. Something's wrong with that. Oh, I know. Okay, so, well, real quick, we can see this Bezier curve thing is looking pretty good to me. But I've definitely messed up what I'm doing with the screenshots. And I'm gonna leave them there, but I think what happened is I didn't call this create save string up in setup, which I really should have. That should do it. Let's check. Oop, 17. There we go. Okay, that's looking pretty good if you ask me. But one other thing I would want to do, actually a couple more things. I want to make those anchor points go up and down as we as we're running this to just give this whole sketch more action, more motion. So right up here we have anchor X, anchor Y. We want to change this Y value, and then since we reference that later for the control points, we are good to go. Okay, so let's do a new noise function. So angle noise value is what we used before. So let's do height noise value, and that will be a string, capital S there. And we'll do noise. Again, X, Y, Z. You know, I really want to make sure that it's not pulling from the same noise like space. So this may be a little bit arbitrary, but why don't we set the X value to, well, we could just set it to 0, and then we'll travel through the Y portion of the space instead. So we can do frame count like before times, we're going to use the same noise scale. We might later find that we don't like that, but we'll do that some other time. And then we'll still offset it by I again. That seems good. And then we need to feed that into another map function. So this is a control angle. So why don't we, well, no, it's really, no, it's anchor Y. So anchor Y of I equals map of height noise value, height noise value, and that's going to have a low of 0. It's going to have a high of 1, and we can choose how much this moves here. Now we could say it's going to vary from, see, height over 4 to height times 3 divided by 4, and we'll get rid of this. And I think we'll now see that bouncing up and down as we go. Cannot convert from float to string on line 40. Oh, I don't want a string. I want a float. All right, look at that. So it's pretty jumpy, but I like it overall. I also think that now that we have this working, let's go ahead and get rid of these sort of indicators that show how it's all going on behind the scenes, and we will reduce the noise value, or the noise scale. Let's do, yeah, maybe 0.01 is the ticket. We'll at least try it out. And I think it would look nice to have thinner lines for the Bezier curve, so let's change that back to 1. And what else was I going to add? Oh yeah, so I really like when those lines kind of fade away over time, And there is a pretty easy, fairly effective trick for doing that. Let's just run this real quick to see. Oh yeah, that looks so cool. It's definitely alive. I like that. I'm watching this left side. It almost looks like it's staying pointed down. But no, it is varying. Okay. Well, so that looked good. So right here, I'm drawing a white background on every draw loop. I'm going to go ahead and move that to the setup. And now what I'm going to do is at the end of every draw, well, it could be at the beginning. Yeah, that's easy to keep track of. Let's just do that. Let's set a fill that is a really, like, almost completely transparent color. So we will do, if we do two values, it would be grayscale and then the transparency. So we'll do 255 for white, and then we'll set an opaqueness of 10. So it will be almost totally transparent, and I want to make sure that we are not drawing an outline around it. And then we're going to do a rectangle that's going to be from 0, 0 to width height, and now we should see things fade. Pretty nice. One thing that's always been interesting to me is using this method that always leaves this kind of relic of the line behind and that never fully disappears. So that's going to be the topic of a future exploration that we do in converting this over to an object-oriented way of programming, and then we'll see a good way to handle that. Also want to just see if we change a few other values, like we're changing the control radius to something smaller now. How does that change what we see? Yeah, so there's not as much smoothing going on here. Actually, see, there's a little, it looks like there might be a little issue with what we're doing. Why don't we turn our guides back on and see if there is an issue? X, Y, anchor, anchor, right, right, left, left, X, Y, X, Y, X, Y, G plus 1. Those seem fine. You know, maybe it's just a little offset with some of the rounding for pixels or something like that. I'm gonna not worry about it too much right now. Cosine sine, cosine sine, xy, xy. So what if we make this larger, like 100? Now let's try it with many more anchor points. Uh-oh, it's going off the edge. Something's wrong. Oh, here we did our map 0 to 4, and really we want it to go 0 to anchor count. Whoa. Well, that's a different look. Now let's just, to try something else again, reduce the control radius. Now the lines are drawing pretty slowly on my machine, but it's largely because I'm recording the screen and a video and saving the screenshots at the same time. So your results may vary. Yours might screen right along without that constraint. But because I'm saving all of those screenshots, I can easily convert those into a video later. Okay, well everything seems to be working pretty well, and then you can go ahead and get in there and change whatever settings you'd like, whatever math you think would be interesting. You can change the look and go from there. All right, that was fun. It was quite a long process, but I think really rewarding too. One thing that I would still like to do in the future, and we'll save that for another video, is get more control over those lines that we're drawing. I think it looks really nice to have them fade into the background, but you could see there was that artifact that just wasn't going away. And a way to take control of that is to convert this program over to an object-oriented style, where each one of those lines would be an object, and then we can refer to those objects and do whatever we need to do, whatever we want to do. And that would be a great expansion of our skills, our programming skills and processing. It's super powerful to be able to use objects like that, or classes. And we'll save it for the next video. So thanks for following along. I hope you learned a lot, and we'll see you next time. Alrighty, bye.